Hello guys, welcome back to Pre-Algebra with Miss Betsy. I'm going to be working and solving the skill check problems from section 7.1 in your text today on page 219. This is the first edition of Pre-Algebra for Christian Schools, published by Bob Jones University Press, section 7.1, multiplying rational numbers. And this is the companion video, short little clip where I work through about 10 sample problems. So, Sam, I'm recording this today. I think it's maybe the 19th of December 2013. So, hope you are doing great this week. So, let me pray. Father, I thank you that you love us. I thank you that you are more than enough to meet every need of our lives. And I thank you especially for this time of the year when we remember the birth of your Son and the greatest gift that could ever be given to us. Father, help us to understand the material before us. Pray in Jesus' name, amen. Okay, Connor, recognize the book that you got me. So, joke for today, which you probably already know because you read the first few pages. Why did the robber wash his clothes before he ran away with the loot? Well, he did that because he wanted to make a clean getaway. So this should be a pretty quick, straightforward lesson for you guys. This whole chapter, a lot of it really ought not to be too difficult. It's a review of fractions. If it's not a review for some of you, it's basic, straightforward material, information about how you multiply fractions, which are actually rational numbers, together. If you don't already know how to do that, you simply need to learn the method, get enough practice, and get that under your belt, because believe it or not, this whole deal with fractions that we're working on is what causes so many of our parents, so many adults, just to freeze up in terror over math because they're afraid of the fractions. So just buckle down. I know it's right around Christmas, but you can do this. Section 7.1, the first examples, there are two of them that I'm going to write, and these are from our skill check. First, we have this statement given to us: 2/3 times 6/7 is equal to 21 over, not over 4, 12, okay, dyslexic here, 12 over 21. 12 over 21. And our second problem is 10/3 times 2/3 is equal to 20 over 9. So they've already done the multiplication for you, and what you learned in this lesson is that when you multiply fractions, you multiply the numerators together. 2 times 6 is 12, and then you multiply the denominators together. 3 times 7 is 21. And you've heard me be saying all year that you have to have your fraction expressed in lowest terms. And I say you've been hearing me say this all year. You haven't been hearing me say that a whole lot, but Algebra 1 kids have been hearing me say that quite frequently. So what does it mean if we want to have that fraction in lowest terms? We have to make sure that there's no number that you can divide the numerator and the denominator by. And there is a method that you can use to figure it out, but for now, can you divide these by 2? Well, no, you can't divide 21 by 2, can you? Because it's not an even number. Well, what about if you wanted to divide both those by 3? You can divide both of those by 3. Remember your divisibility rules, which I'm not going to take the time to review now. But we can divide both 12 and 21 by 3. So we're going to reduce that. And they show this in your book, like saying 12 divided by 3 divided by 21 divided by 3. And I didn't really leave myself enough room here to complete this properly, so I'm going to squeeze it in. What's 12 divided by 3? 12 divided by 3 is 4. 21 divided by 3 is 7. Now, there are no factors left that you can divide both 4 and 7 by because they're prime. 7 is prime, 1 times 7, and 4 is 2 times 2. There are no common factors. So now we say that this answer here has been reduced to lowest terms. So this is in lowest terms. Not in lowest terms, however, is our first answer that they gave us in the book. So while it's true that you multiply 2/3 times 6/7, and you do in fact get 12 over 21, that's not the full and complete answer because it has not been in lowest terms. 4/7, however, is in lowest terms. Now we want to look here and say 20 and 9. Are there any common factors there? Can we divide both of these by 2? No, because 9 is not even. Well, what else can you divide 9 by? You can say 3 times 3. Can you divide 20 by 9? No, you can't. So this is in lowest terms, but what is this actually called? This is called an improper fraction. What's an improper fraction? That has a larger numerator than denominator. The numerator is the number on the top of the fraction. The denominator is the number on the bottom. And I have said that as long as you have this reduced to lowest terms, you can leave it at that. But let's see what our instructions say here. It says, rename each answer in lowest terms. If you choose to leave it at that, that's fine. Moms, whoever's checking these homeworks, if you're trying to match these answers exactly, sometimes they're going to take this and make this as a mixed number. It's okay to leave it as an improper fraction. It's okay to write it as a mixed number, which I'm going to show you in a second. Always ask me if you get confused. Okay? How, now that this is reduced to lowest terms, how do you convert a number from an improper fraction, can't figure out how to get my marker on, to a mixed number? You take the numerator and you divide it by the denominator. 2 times 9 is 18, and we have a remainder of 2. The remainder becomes the numerator of a fraction, numerator over denominator. So reduced to lowest terms, 2 times 9 is 18, okay, becomes 2 and 2/9. So you now have 2 and 2/9 here is going to match the answer in your teacher's manual. I'm perfectly fine with 20 over 9, but if you want to match exactly, they just need to understand improper fraction, mixed number, both have the same value. In pre-algebra, both of these are acceptable, but in truth, this, working in the world of algebra, is a better answer than the mixed number. Okay, I'm sorry for the confusion. I don't know how to make it any better. Okay, let's look at problems now 3 through 10. And let's work through these pretty quickly. Probably you sat down and have already done your assignments, and you might just be looking at this now saying, what in the world could I be wanting to look at this for? So let me fly through these. Here's problem number 3. 1/2 times 3/5. Multiply numerators together. multiply denominators together. If your kids are using a raised dot or parentheses, that's great, because I've said let's get away from using the x as a multiplier, but they're using it in this section. So whichever they choose to use, and I know it's hard for some of us to think, well, it can be this way, or it can be this way, or it can be that way, but that's just a part of being familiar with your terminology. 1 times 3 is 3. 2 times 5 is 10. There's nothing that you can divide. 3, you can't divide by 10 by 3. So this is our answer. Multiply the numerators, multiply the denominators. Now, for problem number 4, we have 2/5 times 1/6. When you multiply fractions, you multiply the numerators, and then you multiply the denominators. And this will give us 2/30. Is that our answer? Is it reduced to lowest terms? No, it's not, because these are both even numbers, which means that you can divide both of them by 2. So let me just pull this problem up here. 2 divided by 2, 30 divided by 2. That gives us 1/15, 1/15, as our fraction reduced to lowest terms, or as our rational number reduced to lowest terms. Now, there are 2 ways when you're multiplying fractions together that you can make sure that you end up with a number that is reduced to lowest terms. The first way is what we've done here. We multiplied numerators, multiplied denominators first, then we looked for a common factor and we divided those common factors. The second thing that you can do is you can look for a common factor first, or you can look for numbers, a number that you can divide from the numerator and denominator first before you multiply. So we have a 5, which is a prime number. There's no 5s in the numerator. But look, you can say 2 divided by 2 is 1. 6 divided by 2 is 3. Now, in our numerator we have 1 times 1, and our denominator we have 5 times 3. So, it makes, now here, big deal, 5 times 6 is 30. The multiplication is not much of an issue, but there will be times, and I'll show you some by the time we get to the end of the skill check, there will be times where it is definitely to your advantage, this is called canceling common factors, to cancel first, then multiply. So I'm going to put this over here. In general, cancel first, then multiply. Is that a hard and fast rule? No. If it bugs you to cancel first, don't do it. But you will be making some extra work for yourselves. But sometimes extra work is fine. There are things that I do where I know I could do them faster, but I've got this method that I go through, and it helps my brain work that way. Okay, that's example 3 and 4. For skill check 3 and 4, let's see what we have next. As soon as I get all of this mess erased. Example 5, we have 5/8 times 2/3. 5/8 times 2/3, you can multiply numerators together first. And you have 10 24ths, but those are obviously both even numbers. So you're going to need to divide both the numerator and the denominator by 2, and we end up with 5/12. as our answer. This is what you would, the work that you would show if you multiplied first, then divided. Or then canceled, you divided, which is the same as canceling common factors. If we had done this the other way, where we canceled common factors first, this is what it would look like. We see that we have two even numbers. 2 divided by 2 is 1. 8 divided by 2 is 4. You now have 5 times 1 in the numerator, 4 times 3 in the denominator, and you have 5/12. So regardless of which method you use, whether you choose to multiply first and then divide by common factors, or whether you choose to cancel first and then multiply, you will get the same answer. What I'm going to do for the rest of the problems, though, I'm not going to multiply out. I'm going to cancel common factors first. And I'm just going to fly through these real quickly. You can pause the video if you want to see what's going on. Number 6, if you need to look at it more closely, we have 8/9 times 15/16. And this is a case where it's good to know multiplication facts and know that you can divide. This is 8 times 1, this is 8 times 2. So 8 divided by 8 is 1, 16 divided by 8 is 2. 3 times 3 is 9, 3 times 5 is 15. So we're going to divide both the denominator by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. There are no more common factors. In our numerator, we have 1 times 5. In our denominator, we have 3 times 2, which gives us 5/6. If we had multiplied, we're going to end up with, what? 120 divided by 4 divided by 144. And you can see that it would take more work to solve the problem. Problem number 7, we have 3/7 times 2. Anytime you have a whole number or a mixed number, you want to convert to a fractional form, to the form of a rational expression before you multiply. You have 3/7. 2 can also be written as 2 divided by 1. You multiply numerators, you multiply denominators together, and you end up with 6/7 for your result. Next, you have problem number 8. 6 times 3.5. 6 times 3 1/2. Mixed numbers you convert to improper fractions. Whole numbers you convert to fractions as well. 6/1 times 3.5. Convert that to a mixed number. 2 times 3 is 6, plus 1 is 7/2. Okay? Now I'm going to be able to, what in the world did I do? 7/2. 42, 21. 6 times, okay. Looking at my book here, and I'm mixing up problem that I'm working on in a different answer. This is what I want to do. 6 is 6/1, 3.5 becomes 7/2. Now, both 6 and 2 are divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. What do we have now in our numerator? 3 times 7 divided by 1 times 1. 21 divided by 1. Which of course is simply the whole number 21 for our solution. 2 last problems to do. Problem number 9, we have 1 2/3. 1 2/3 times 2.5. How do we do those? Convert both of these to improper fractions. 5/3 times 5/2. There are no common factors here. You have 25/6. This is okay, Mom and Dad. There are no common factors. You can divide 25 only by 5 and 25. You cannot divide 6 by 5. But here, they're going to go ahead and take this improper fraction and they're going to convert that into a mixed number where you would have 4 1/6. This is okay also. My preference, leave it as an improper fraction reduced to lowest terms. This is okay, this is what your book says. My preference is that you only use mixed numbers when you're answering a word problem. But either of these are okay. Now, one final example. Problem number 10 on our skill check is 10 2/3 times 8 1/4. 10 2/3 times 8 1/4. Once again, we convert these to improper fractions. 3 times 10 is 30 plus 2, 32/3 times 4 times 8 is 32, 33/4. This right here is a perfect example of why, in general, this is the best policy to follow. Perfect example of why you want to cancel first and then multiply. I'm not going to do it, but we have 32 times 33. Okay, 30 times 30 is 900. So we're going to have a very large number in the numerator if we don't cancel first. We're going to have 900, it's going to be more than 900. Over 1,000 divided by 12, and then your brain sort of goes tilt and says, what am I going to divide by? However, 4 times 8 is 32. So 32 divided by 4 is 8. 4 divided by 4 is 1. And you would probably recognize that 3 times 11 is 33, or if you don't recognize that, surely you see that you can divide 33 by 3. 33 divided by 3 is 11, 3 divided by 3 is 1. And all of a sudden, a problem that could have been yucky is very easy. Do you have to do it this way? Nope. Can you multiply first? Oh, of course you can. On a problem like this, why would you want to? But just know that if you've got your brain set that way and you miss the fact that you could have canceled, you can still take these big, large numbers, and I'm not going to take the time to show you that, but you can still go the longer method, longer route, and you will end up with 81 as your answer here. That's all I've got for these, and I will let you go.